a particle of energy E scatters off a repulsive spherical potential that is given here. In the lower energy limit, the total scattering cross section is given here, and the value of K that has been used here is given here. Now, in the limit that V naught goes to infinity, the ratio of the scattering cross section to the classical scattering cross section of a sphere of radius A is what? So the classical scattering cross section is given by, I'll write it as sigma C is pi A square. Now let's evaluate the scattering cross section in this case. The scattering cross section, let me go to a new page, is given as sigma is equal to 4 pi A square 1 by tan hyperbolic of K minus 1 the whole square. Now notice that as V naught goes to infinity, from this equation given here, V naught is going to infinity, therefore K also will go to infinity. Therefore it means that K also goes to infinity. So we have to evaluate this term in the brackets in the limit K going to infinity. So let me write out the term. So so we're going to evaluate tan hyperbolic of K in the limit K going to infinity. Now this can be written in terms of exponentials. So sin h is nothing but, so tan hyperbolic of h is sin h by cos h, right? So sin hyperbolic function, this is the sin hyperbolic function in terms of exponentials, and this is the cos hyperbolic functions in terms of exponentials. So this just becomes 1 minus e to the power of minus 2 ka divided by 1 minus 1 plus e to the power of minus 2 ka. Now this has to be evaluated in the limit K going to infinity. So this becomes, so when you substitute for K going to infinity, the exponential terms will become 0 and your answer would be 1. So therefore, we evaluate this term to be 1. So therefore, in the limit K going to infinity, this entire term will become 0, and what will remain is of sigma will be 4 pi A square minus 1 the whole square. So only this minus 1 will remain. This entire term will go to 0 because K is going to infinity. Then any number divided by infinity is 0. So this term goes to 0 and we have minus 1 the whole square. So this is nothing but 4 pi A square. So therefore now the ratio, we are asked to find out the ratio. So sigma by sigma classical is nothing but 4 pi A square divided by pi A square, which is nothing but 4. So this is your answer. So the right option is given by option A.